All right, good morning, everyone. Welcome to our GibbsCAM and Coffee series. We've taken about a year's break on this one, but we decided to get back at it as we had some time and we had some cool topics we thought we wanted to cover this year. So we're going to start this one off with going through our 5-axis portion of GibbsCAM and explaining how it can be beneficial to those that don't have true 5-axis machines. As the name would dictate, you would think just for 5-axis, but the 5-axis portion of the software has a lot of really useful strategies and capabilities that other portions of our software do not have that can be used on 3-axis and 4-axis mills, as well as obviously the 5-axis side of things. So we're going to dive into that. We've got with us today Dave McCrae, who most of you would know through email and phone call, and he's probably trained you or someone you know over the last 20 or 30 years. And the newest addition to our team, Bill Reed, who brings with him a ton of experience on the CNC applications engineering side and the tooling side, as well as a lot of experience as a GibbsCAM programmer. And most importantly for this conversation, a lot of experience in the 5-axis side of GibbsCAM. So without further ado, I'm going to let them dive into some sample parts and explaining some of the strategies that they have utilized over the years and that they find successful that aren't necessarily tied to just 5-axis parts. So let's let Bill become the presenter here.
Hi, good day everyone. My name is Bill, and I'm going to show you a handful of parts that, for a couple of reasons. The first one is to show you and give you some ideas of the functionality of the 5-axis module in ways in which you can use it without a 5-axis machine, whether it be 3 or 4 axes. So all of these toolpaths I'm going to show you are 3-axis toolpaths. And the second reason is possibly even to provide justification if you're thinking or looking at the 5-axis module in ways in which this module will give you advanced toolpath creation, decreased processing time, and all in all, better quality toolpath for some of your projects. So the first part I'm going to show you is a very basic little puck here with 3 holes, but it's a common issue in which smaller shops or people that are creating fixtures sometimes see. So we have 3 holes, each with a different angle countersink, a 90, an 82, and 120. And in addition, there's a radius on the part, which is 2 millimeters. So this part would ideally require at least 4 tools to generate these different features, but I'm going to show you how we can do it with just a single 3/16 ball end. So in looking at how we would traditionally do this with the contour tab, you could basically take a 2-axis toolpath and impact it on the radius of the part. Now, there is some segmenting there, and there's some step downs, because you would not be able to do a spiral ramp down on this part. But in using the 5-axis module, you see I have the same step over. I have a nice customized lead in and a lead out, and I'm actually starting from the bottom up on this toolpath. And this toolpath, the exact same parameters you can use to generate the 3 different 90 degree, 82, and 120 degree countersinks for these holes, instead of using 3 different countersink tools. So if I run this simulation, I'll slow it down and let you see it start. So you see it's coming in from the bottom of the part and using the periphery of the tool instead of taking the tip of the tool and digging in the top side, which will give you better chip performance and better tool life. And it does a single spiral all the way up to the top of the part, and the same thing with the countersinks. Starts in the bottom of the countersink, spirals up, and does each of those surfaces there. So very simple way to save you some tool selection in using the 5-axis module. The second part I'm going to show you is using the 5-axis module in a way that you really wouldn't think to use it. We're actually going to be using this to do some plunge run. So this particular part here is a elliptical top cross shape, and I do have a couple of different angles here with a radius in between and a radius to a flat bottom. So when trying to remove this material, if I bring up the toolpath here, I'm actually using the 5-axis module with the strategy that is morphed between 2 curves. So I've selected one of the vertical curves on the edge of the part and the second vertical curve, and then the drive surface, and I'm leaving a little bit of stock there for the finish. So in creating this tool path, I'm able to generate a customized lead out, which gets the tool away from the part, enables the chips to clear in the bottom of that cavity, and also prevents the tool from rubbing on the beginning of the next pass. And I'm generating a step over about 1/3 the diameter of the tool, which is a 1-inch punch rock. The second tool is the same tool, but the second tool path is using the exact same morph between two curve path, but instead of selecting the vertical path, I'm selecting the top edge. Top edge up here, the bottom edge here, and I'm creating a customized lead in and lead out. But what I'm also able to do is I'm able to customize the feed rate in between the end of one pass and the beginning of the second. So if I turn on my utility markers, everywhere you see a black flag is a tool feed rate change. So from a 40-inch per minute contour cutting speed to a 500-inch fast feed repositioning move, I can do that in the 5-axis module. So if I run my simulation to show you this plunge roughing pass, got the machine here. So 1/3 step over going around the elliptical periphery of this part pocket. Now, if you're looking for metal removal, it doesn't get much faster than using plunge roughing as far as metal removal rate. And then the heavy scallops that you see would be taken out by this semi-finish or finishing subsequent pass. So there's a fast feed between the end of the finished pass and the beginning of the next depth of cut. So I can increase that cycle time and show you the finished pass there. Moving on. This next part, there's not much to it, but it does show a relatively complicated multi-face corner radius around the periphery of this gland here, which is almost vertical here. So in looking at the tool path, I'm using the morph between two curves. I select the top edge and the bottom edge and the radius in between. And I'm using a zigzag pattern. So the complex part about this is it actually comes to a sharp point at the end. So the software handles that no problem, and it generates a nice vertical lead in and lead out at the end of the pass. And this is a zigzag path. Using a very similar tool path, I can do this complicated spherical radius and corner radius on the edge of this pocket here. So I'll run that simulation. So again, I'm starting at the bottom of the feature, so I'm using the periphery of the tool where I get the best cutting action on this particular tool. And again, only 3-axis tool path. And the last one I wanted to show you is one that every part's going to require, deburring. So I have a part here with 5 pockets, and they're out of plane. It has a boss that comes up, so these long edges here would be pretty difficult to deburr with a chamfer tool. So what I've done is I've got a 5/16 lollipop. If I look at the process data, you notice I only have one tile. And this one tile, I've selected the entire part. The software is smart enough to know where on this entire part that I have a sharp corner that requires deburring. And you can see that it's actually deburring the underside of these through slots in this part. So going into my 5-axis module, I have an actual deburring process in here. And you can see it's set to auto detect, so it's going to interrogate that entire solid model and automatically select any sharp edges that need to be deburred. I can set my width of deburr, how many passes, and to show you what this looks like. See, my lollipop comes in and generates that 5-axis tool path and a climb milling pass with a good lead in and lead out for the gouging. And so as I go over here to the slots, I'm going to turn my machine off so I can rotate around and show you how this tool goes in and does the bottom side of the slots with that upper edge of the lollipop tool. As you can see, one model, one selection, one tile, 5-axis to do 3-axis deburring. And that's all for me. Thank you.
Okay, fellas, Dave here. I have got a few examples as well for the 5-axis locked in 3-axis mode. And this first part here, I'm going to show you something that has typically been a problem in the past. Any of you that have tried to cut a channel like this for, like, let's say a bending die or something like that, typically what I would have guys do is try and do it with a contour, and they struggle with it and have trouble because Gibbs in the standard contour cannot track the top side of the cutter. So they would wind up taking an 1.5 inch wide slotting cutter, full radius, and try and cut that, you know, with the same shape. But with the 5-axis module locked in 3-axis, that's not necessary because we can track both the top and the bottom of the tool as well. So this first example here, I've got a roughing tile where I'm actually just choosing my favorite path, morph between two curves, selecting a top curve, a bottom curve, and the drive surfaces, and a few more parameters. And I've roughed all that out, stepping over with that cutter, tracking it on the top and the bottom. So we do a rough and a finished pass with this. So let me go ahead and turn on the machine sim. And show this both roughing and then we go ahead and finish it. Does a really nice job of it. Tracking on top and bottom. So next I've got another part, similar scenario. If I go here, another undercut situation. So if we look at this part, what I've done to make it visibly a little easier to see is an old trick that I've done many times, is to cut the stock in half in the document control because I don't really have a stock body. And my 5-axis pass locked in 3-axis mode, here I'm using in surface pass, I'm just using parallel cuts with tool axis control, once again set to 3-axis. And basically use the same parameters on the inside and the outside. There's an undercut on this outside as well. So let's go ahead and simulate this. And of course I've done some standard processes before to rough that out. So here, go ahead and blow a hole through it, and you're seeing half the part once again. And I'm just doing a straight contour. Now we're going bottom up with that key cutter to form that shape, and we're cutting with the top of the cutter. Well, now we're transitioning to the bottom of the cutter as we roll around that top radius with no problem. And same thing, I'm going to rough the outside here. I'll speed it up a little bit. And now we're cutting with the top side of the cutter is essentially what we're tracking with. And let that work its way up the top. Sorry, I'm speeding it up just so we don't have this video be too terribly long. Let's go ahead and let her rip. And let me turn the machine off for a second so we can see those undercuts being cut in there. Okay. Let's go to a third one here, which is a triangle mesh, which is just a different strategy. Instead of morph between two curves. And the one thing that you'll see within the 5-axis module is there is a ton of different choices as far as what type of strategies you want to use. Here we're driving it based off a triangle mesh, but you could drive it off of surfaces, drive 2D off a wireframe and do some really wild stuff with that. I've done a lot of drill fluting with 2D wireframe geometry within this module as well. But if we look here, this is similar to a volume type path with it helixing down to the bottom and then just doing a step over. So I'll go ahead and simulate this. And so we're spiraling down. It does a really nice job. Cleaning out those corners. So that is just a different strategy that we're using to cut this part. Let's go to this last one, and I give Bill credit for this one. He came up with this model. And it's kind of like a hodgepodge of everything in here. So we're starting off with some 3D volumo, roughing this out. The second operation is a parallel to curve, I believe. So if I go to surface pass, yeah, it's parallel to curve. You select a curve, select the surface, and we'll get this kind of path. The next one is going to be a morph between two curves, kind of showing that, hey, I want to follow from this curve to the bottom curve and just cut around it. That's why that's one of my favorite paths, is because on any part, you're going to have more than likely two curves that you can select and say, hey, just cut between this. Let's go into the next one. Is more of a surface flow type cut. That's parallel cuts though, if I remember correctly. Yeah, it's just parallel cuts. And you can control angles and all that stuff that you want to cut it at. Then we do a contour on this slot in the top. If I get this model out of here, let me bring out the finished part model. And if we look at that and turn edges off for a second, that is a slot that we're roughing out in 2D, but then there's tapered walls here, which we're cutting with the 5-axis module to go parallel to that surface. This next one is blowing that radius on the top. Does a beautiful job of that. Once again, morph between two curves. And this last feature is deburring. And once again, like Bill had shown, we're just selecting the whole model and saying, hey, I want you to deburr this. And the process itself, very simple if you look at it. There's not a whole lot to fill out here. We're 3-axis, this was actually set to 5-axis. Let me switch it to 3. Redo that process. And done, okay? So you get the idea. There's a whole lot that you can do with this 5-axis module. Even though you have a 3-axis mill or a 4-axis, you can lock it in 4th as well and do all kind of stuff that you could not normally do. Just a great addition to our toolbox. So that's all I have for it, Zach. Zach?
All right.
Oh,
Thank you very much, Dave.
Yeah.
Bill, that was great stuff. Hopefully, everybody learned a little something out of that. Possibly take a new strategy back to the shop with them in the use of our 5-axis module, not necessarily for 5-axis parts or machining. So thank you again, guys. Thanks to everyone that attended. Thanks to everyone that could be watching this on YouTube in the future. And again, I want to say thank you. Don't hesitate to reach out to us if you have questions on any of these strategies. That ultimately is what we're here for. And we hope you all have a great day. Thank you again, guys.